go through it. It's another way that we can represent complex numbers, and in fact it's going to be the dominant way that we do so next year. So I'm just getting you guys to think about the unit circle, right? If we have some point on a unit circle with a radius of 1, or it could just be a radius of r, alright, whatever the radius is, that the x value is cos of theta, and the y value is sine of theta, okay? Now we represent complex numbers as x plus I y, don't we, okay? Where x is the real part, the real component, and y is the imaginary component. So if this is true, well you can see we can substitute cos and sine in, and then the shorthand for expressing that is cis, cos I sine of theta. And we have the modulus of z at the start to dictate how far it's going in that direction. So let's break these parts down. So this is what we call polar form. This is the modulus of z. Okay, we know how to calculate modulus already. That's just the square root of the real component squared plus the imaginary component. That's fine. This part here is what we call the argument of z. Okay, and so the argument of z is just the inverse tan of the imaginary component on the vertical component. It's just saying what is the size of that angle. Okay, that angle there is the argument of z. So if we have 2 plus 2i, we need to find both the modulus and the argument, okay? So if we're thinking about what's the modulus of 2 plus 2i, it's going to be the square root of 2 squared plus 2 squared. So we have square root 8. Alright, so in simplest, like if you put that in your calculator, it'll pop out as 2 root 2. I'll accept either. And then the argument of this complex number is going to be the vertical component, inverse tan of the vertical component over the horizontal component. So 2 on top of 2. So inverse tan of 1. Now when we want to put this in our calculator, we want to make sure it's in radians, okay? And that'll pop out with pi on 4. So we've got all the things we need to express it in polar form, okay? It is, this complex number z is going to be 2 root 2 cis of pi on 4. Alright, so you find the modulus goes at the front, you find the argument, pi on 4, that goes at the end, and then you just go to 2, argument, modulus, cis, argument. Okay, let's do another one. We have minus 1 plus root 3i. So to find the modulus, we're going to have the square root of 1 squared plus root 3 squared. Alright, so remember direction doesn't matter when we're talking about modulus. We don't need to consider the negative 1. And so this is going to be the square root of 4, which is 2. Has to be positive because it has it's a length. We need to find the argument. So we'll go to the argument of z is equal to inverse tan of root 3 on minus 1. Now when we're doing inverse tan, we do need to consider whether it's negative or positive, because that will dictate its position on the unit circle. And so this complex number is 2 cis of minus pi on 3. Alright, so with polar form, notice how we've restricted the region. Alright, so we're not talking about, we will never have a value of an argument that is larger than pi, and it will never be less than minus pi. Okay, so we're defining it in terms from minus pi all the way up to positive pi, but never outside of that domain. Okay, let's do the opposite. Let's convert it to Cartesian form. Alright, so the way we're going to do this is we're going to leave the 3 hanging out the front, and we know cis of pi on 4 is cos pi on 4 plus I sine of pi on 4. Okay, so we can look at our unit circle to process these. If you don't have it, that's fine, because your calculator will do it as well. Cos of pi on 4 is root 2 on 2. And sine of pi on 4 is also root 2 on 2. And then we can distribute the 3. 3 root 2 on 2 plus I 3 root 2 on 2. Alright, so there's two ways we can express a complex number. This is called Cartesian form, and then we have polar form. Next one here, 2 cis of minus pi on 2. That's going to become 2 cos of, I'll leave the 2 out the front for now, minus pi on 2 plus I sine of minus pi on 2. Now sine of, so when you put this in your calculator, we'll look at the unit circle. Just how we do a negative angle on the unit circle, we're going back pi on 2, that's going to be this position here. Cos is 0, sine is minus 1. So we're going to have 2 times 0 plus I times minus 1, okay, which leaves you with minus 2i. It's a number that's purely imaginary, there's no real component to it. So we have Cartesian form, and we've moved from polar form to Cartesian form. And over here, we've moved from Cartesian form to polar form. Just different ways of expressing a complex number. So that's going to be enough to just get a start on 2D1. And then I'll talk about the rules associated with 2D2, maybe in about 20 minutes or so.